Good morning, all of you. Myself, Ashish Desai, Assistant Professor, Automation and Robotics Department. Today, we are going to discuss regarding the PLC circuit. So, already we have discussed regarding the basics of PLC. So, now we are going to discuss regarding the PLC circuit. So, first point we are going to discuss here the PLC input output instruction symbols. So, first of all, we discuss regarding the input instructions. So, in normally open switch, this is about normally open switch symbol. This is called as normally open switch symbol. Here if you put the value is 1, output should be on. If the value is 0, output should be off. That means what? Whenever this switch is on or any that push button or any that sensor is on, then output should be on. But if it is value, or you can say this is off, the output should be off. So this is called as normally open switch. Similarly, we can go for the next time, that is about next term is that is about normally closed. If the value is 1, output should be off. If value is 0, output should be on. So this is about the normally closed switch. So here we are using for the continuous supply. So if you can say if value is 1, so output is off. So off value is there, so output should be on. So reverse of this normally open switch, and this is about output instruction. So output is our this symbol indicating. So output should be the coils, or can say different coils is there. Then we are seeing the different that siren. And then we can say this is about the uh, new thing related with your uh, lamps. Then your different output like lamps. So here we can say that output should be required to be any one point of view. So your switch, that emergency start top button, that can be considered as a that indicating lamp is there. So this is considered in the output. Your that motors is there, then your actuators are there, so you can consider as an output. So this is about the basic circuits. So if it is two inputs are present, so here can say that this is about two vertical lines. That two vertical lines is called as power rails, and then two input is are in parallel, and output is at the one end. So input is on a left hand side and output is on right hand side. So here if it is input one is on, output one should be on. So this is about similar thing about input 2. So if input 1 is absent, or can say 0, but input 2 is 1, then output 1 should be on. So this is about the OR circuit. So OR circuit means what? Any one of the switch from input 1 and input 2. So it can be on your output 1. So this is about the basic circuit for the OR. Then next, similarly, we can discuss in the AND circuit. So here two input are present. So similarly we can shift it like this. So two power rails are present, and then two power rails with your respect to two input module, that is about input 1 and input 2 are in series. So here the input 1 and input 2 is should be on. So both are should be required to be on, then and then only output 1 should be off, 1 on. So that means what? Input 1 input 2 is required to be on, output 1 should be on. If it is input 1 off, input 2 on, then output 1 should be off. That means what? There is should be always remember that both input is on, then and then only output 1 is on. So this is about the AND circuit. So this is the difference between OR and AND circuit. So OR circuits is nothing but the two inputs are in parallel, and AND circuit the inputs are in series. So parallel is called as OR, and you can say the input are in series is called as AND. So this is about the OR circuit and AND circuit. So now we are going to discuss the different type of circuits. So in that case we are discussing regarding the risk agreement circuit. So we are using the two normally open and two normally closed switch. So in first case, or in first rung means what? First row. So in first row, switch 1 and switch 2 is in series, but switch 1 is called as normally open and switch 2 is called as normally closed. So then and then only the light. So there is our output. So there are different types of output is there. So actuators are there, motors are there, lamps are there, different type of indicating lamps are there. So this is about the case of output series. So here we are look at this. So we are arranging like this. So switch 1 and switch 2, this is one normally open. So switch 1 is our first rung, we can attach like this, and switch 1 is here normally closed. So here switch 2 is normally closed and switch 1 is 2 is normally open. So if what will be happen, so if it is different values there, suppose switch 1 is 1, that value is 1, and switch 2 is value is 0, what will happen? Switch 1 and switch 2, so that's again I repeat, switch 1 is about value of is 1 and switch 2 is 0, then light should be on. Here switch 1 is 0 and switch 2 is 1, then and only output should be on, that is light is on. That means what? There are two different value is present for the first rung or second rung, then and only that dissimilar value is indicating the output should be on. So dissimilar value means what? 1 and 0. Suppose value is 1, here 0, so output should be on. Here 0 and 1, then and only output should be on. But if your case is about if this value is 1 1, similar value is there. Suppose switch 1 value is 1, switch 2 is value 1. What will happen? Output should be off. Switch value is 0, here also 0. Output should be off. That means what? Similar value is does not allow your output in this circuit, but if your dissimilar value is there in between first rung or second rung, that can be your output should be on. So this is about the disagreement circuit. So this is normally is allowed for single light to be controlled by two switches in a room. So this is about called as a disagreement circuit. That means what? We are using one single output by using two switches in a room. So this is about the disagreement circuit. Now we are going to discuss regarding the handed tied down and anti-repeat. So here we are choosing by the two-handed switch. So normally in industry, suppose your operator is confirmed with your output, then only the left start and right start will be pressed out, and then output should be on. So this means what? The left start and right start is a is a quicker one, as well as you can say as the press at a time, then and only output should be on. That means what? The out that operator is confirmed about your output, and then the system will be actuated. So this is called as two-handed run actuations. The next is about anti-tie down and anti-repeat. So this means what? Suppose your that left hand is pressed, then S1 is engaged for two rungs, and right hand also be pressed, then S2 will be engaged. So here because of S1, S2, so this can be CR1 goes to be on if it is your first output is on. So similarly, we can go for the next category. So S1, S2 is pressed out, then anti-tie-down is on. So this is about for 5 minutes seconds. So it can be continuous your second output. That means what? First is this one on, and after that this should be continuously on. So this is about the machine will start and stop. So whenever your the complexity of the object complexity of the machine is there, or can say if it is that heavy task of the object is there, so we can apply this type of system for the machines. The next is about always on and always off. So here the circuit is called as first always on circuit. So we are discussing regarding here the always on contacts. So whenever the input 1 and input 2, this is about two switches we are using there, but we are using input 1, input 2. Here we can consider as a 1 value, and input 2 value is 0, then relay 1 is on. So this condition we satisfy for the first condition, or that conditions intermediates about relay. So that relay is continuously on for the system. Now next is about always on and always off. So in always off concept, so here we discuss regarding the always on. So always off, that means what? Here the one input one value is 0. So that means what? Here is continuously off circuit, that is about relay circuit. So we are arranging like this in series, so we can get the always off circuits. So now next about nesting of ladders on more than one rungs. So here we are arranging different type of rung in case of that. So here input one is on, relay is on. So relay is on means what? The second output is on. So more than rungs we are adding step by step. So we can call it as a these circuits. So next circuit of we are using for fail-safe circuits. So OR logic functions with four switches. So here we are using four switches and siren is on. That is your one output is there and we are using four switches. So any of four switches we can use it. If it is fails, what will be happen? So this is open wire connections. Because of that should be, if it is switch 2 is fail, so we can use any one switch, that from switch 1, switch 3, switch 4. So that means what? Switch 2 is fail, but the circuit is working because of switch 1, switch 3, switch 4. So that means what? We can engaging of these three switches properly, or any of three switches properly. That means what? If anyone fails, it can be working will be silent. So this is about the main motto of the fail-safe circuit. So if any case happen that switch 2 is closed, switch is 1, 2 or 3 is failed, or 4 is also failed. So you use the 1. Because of this, the arrangement, the operator, or can say this machinist in can operate every time your operations. So this is about the possibility we are giving with the fail-safe circuits. So we are arranging by this OR functions, and that means what? Your four switches you maybe increase up to 5 6, and then we have we can keep the up to the limits, and then we have using the your output switch. So this is about the main thing about the fail-safe circuit. So here also we are engaging with three. This is about circuits we are arranging in the switches is in parallel way. But if you say in a series, that should be switch 1, switch 2, switch 3, and switch 4 is in parallel. So these are the four engaging is possible, then and then only the fail that your CR1 is on, and CR1 is on that time, so it can be discontinue, your output should be siren. So whenever four switches is pressed, the CR1 is energized, and CR energized means what? Siren will be, that can be ringing your output. So this is about the main case about the fail-safe circuit. So where use this fail-safe circuit for the AND purpose? Suppose your output is important one, and that time we are using switch 1 to 4, and if it is any one of that fails, so we can easily operate with the different type of switches. But in that case, what will happen if you use this parallel in a switch? So switch 1, switch 2, switch 3, switch 4. So if it is your circuit is required to be power should be on, but if you not required, so any one of the switch you can use it. For that you can the output should be off. So if it is possible is there in machines, uh, we can arrange this type of circuit also, and your that operator should get alert by the system. So this is about the main thing related with fail-safe circuits. Now we are going to discuss regarding the next point, that is about Boolean algebra equations. So this is the circuit we are forming for the Boolean algebra, because it is easy to read for the or can say any value you can put in this format. We can get the equations, and these equations will help to find out the output values, what will be next point, or what is the this is what, that is why we are giving for the Boolean algebra equations. So how it can be derived? So first of all, we discuss this problem first. So already we have that giving the circuit, that is B, that is first B is normally open, A is normally closed, and C is normally open, and X is your output. So this is about the first rung, and we are creating the first equations. For that was normally open. So these are the three, that BAC is an normal, is normally it is in series, but switches is like this: B is your normally open, A is normally closed, C is normally open, and X is your output. So how it can be written in the format of Boolean equation? So output is your at a right hand side, so we can write as a X is your left hand side. So this is X is equal to, so output is equal to B as it is, we can write, because normally open is there, so we can write as it is. A is there, so A is having normally closed, that's why I can write A bar. Okay, So normally contact is there, normally closed contact is there, you can cite as a bar and C into C. So this is about the main thing related with Boolean algebra equation. Now next is about second equation you can write as. So you remember that normally closed contacts we can write as a bar. Is it clear? So normally closed contact we can written as a bar. So D bar C. So you can write this equation in the format is in the Boolean algebra. So A is equal to, or I can write B bar into C, B bar into C. So B bar into C, and this is in a series. So sorry, parallel. So that's why I can say D plus E plus F. So I can write D bar because of normally closed, D bar into E into F. So so the D bar into in short plus and E plus F bar. So this is about equation for the Boolean algebra. So B bar is there, C is there, and these are in the parallel. That's why I can write D bar plus E plus F bar. So this is about the Boolean equation for the generating for the ladder. So it can be helps to your find out the different values. So if you put the values here, 0, 1 like this, accordingly we can connect this, and then output should be if it is on or off, we can easily identify it. So this is about the help of Boolean algebra. So this is about the discussion on the different PLC circuits. So today we are discussed already these points about the decision agreement circuit, fail-safe circuits. Then we can discuss about the always on, always off circuit, uh, or an AND gate circuit. So last point we discussed regarding the Boolean algebra equations. So next point we'll discuss in next lecture. So we are discussing also third problem. So similarly we can do this activity with this current situation. So we can arrange this B bar. So likewise any can you can do. So B stands for, so here normally close is there, so you can write B bar. Okay. So likewise you can write this. We have arranging in the series. So at that time we can write as an into. Okay, and if it is parallel you can write as a plus. So this is about the main thing related with ladder program. Okay, so this is about the main thing related with PLC circuit. So you can solve any type of problems, and you can put the value of any one of this, and then we can get the value of output of this. So this is about the main circuit related with PLC. Thank you.